Why? Said why? Huh?
Well, I got a call from one, or a message from one, and he's running late, but he will be there. I don't know where everybody else is, though. Oh, hey, Jared, how you doing?
Hello. Doing all right.
Finally got my internet back. The only bad thing about living out in the country like I do is, I mean, before it was never a big problem. It was kind of, you know, that's kind of the thing you expect, living out in the country. I get strange power outages, strange outages, but when I have to do something like this, it's like, all right, come on, But we literally had what was it? Our service guy was in Sacramento. We were on a call with, and he was trying to do everything remotely, and it's not like it's I mean, they're a smaller outfit, but they do like, a fair region, farmhouses and all that kind of crap. So it's kind of interesting. But I don't know what it was. I know one year we actually had mice had gotten into the what you call it for the telephone thing. It's the I can't even think. One of their large junction points, basically. Where all their wiring's all together. Mice had gotten in there and kind of played a little havoc with their wiring in there, I guess, and it took them like a good part of the afternoon and almost into the evening before they got everything going again. So I always say mice and critters can be your biggest enemy when it comes to wiring. Because they'll get into the craziest places where you wouldn't normally think they'd be, but But now I got to go through pretty much all this afternoon and try to get everything caught up for solid state, because I got a couple of labs I need to do, and then I need to get the chapter homework in and all that. So hopefully I get all that done soon. And then I got this class, and I posted. What did I post here? I think we had another. Yeah. Yeah, so we got the chapters 15 and 19 and 11 homework. Everything else, hopefully everybody was able to get through everything. Seemed like it. Oh, you're the only one on right now. I know Joseph texted me and said he was going to be a little late.
I imagine you have more people in class, but the current thing, maybe people drop classes. I mean, you drop this class, a lot of people drop the class, I'm guessing.
For what? Oh, are you?
This class, I imagine you probably had a lot more people in this class, but yet they all dropped because of the corona thing.
Yeah.
I'm probably gonna retake these courses anyway on the fall, just because I don't feel like I'm really learning them that well as I did in person.
What? This class or
I think both classes. I think these both the classes because I think I would probably take out even after even if I get passing score in this class, I'll probably take them on the fall if it's back.
okay. Yeah. Yeah, it's been well, and I mean that's the whole thing, and that's been the hardest part because the I mean we're missing, you know what I mean, the hands-on lab part is a key component to some of it.
Also like on every circuit, I don't know how do you how it's like there's some of the things symbols I don't recognize that like on the chapter 12 on the like lab 12. There's some symbols I could recognize that I couldn't really get a working version, a working thing
For
on
in solid state?
for lab 12.
What didn't you? Hold on here. Da, 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 da. Let me let me flip around here a minute. So I'm not using anything complicated, I don't think. Hold on here. Give me a second. Let me pull this up. Lab 12. Because that was the. I mean, you're talking about the non-inverting op-amp?
Yeah, I'm opening the lab sheet right now.
Oh, it's not the inverting one.
On the schematic, I couldn't get mine working on this schematic. What with the schematic?
Well, because I mean, it's a basic op-amp, right? Now you got to remember with those things, you got two inputs, right? And I mean, you have the two. Well, I can do a little video thing on it if you think that's what we need, but because there's two. Hold on here. Oh, man. Have me showing the whole class this, but
We can do tomorrow. Or I'll get on early probably tomorrow. I can show you and show.
okay, yeah, because I can actually, because I can jump on the. There's no reason why we can't do the simulator during the class session and have you guys talk about it, and then I can show you how it's supposed to lay out and everything. That'll be no problem. In fact, let's do that. Oh, let me make sure. I believe I'm recording here.
It's recording.
Okay, good. So when I go into these full screens, it changes my whole layout and it gets hard to see. It's like, oh my God. But yeah, well, this is where we jump around a little bit. And it's a good thing because like in chapters 15 and 19, we talk about now we start getting into like special outlets, special receptacles, special connections. And large, it's like the large appliances in the house, right? Because as far as now we've gone through at this point, we've looked at what we need to have as far as what we get in our service entrance, right? So we have the overhead, which is the mast, okay, or we have the underground pool, and how to size that, and even if you're using Romex and stuff, and that's a thing too, right? Even if you're allowed in a residence to go ahead and use, the non-sheet metallic, anything outside still has to have a good degree of protection, okay, right? So, and then the outside, so the mast, we're actually dealing with a fairly good sized piece of conduit. And in fact, the mast one, you usually have that one, and that's why you'll see in some cases you'll go through, they got two types. Rigid makes a pretty good one, but a threader, where you're literally taking the pipe and you have to put a pipe thread on it so it'll screw into wherever you're putting it and whatnot. Unless, of course, you're using PVC, and it's become more popular. I mean, the Schedule 80, and that's the thing too. You got to remember, there's Schedule 40 PVC, which is the white stuff, and that's okay for some applications, but you got to think of it as being the more flimsy. And then they got the Schedule 80 PVC, which is the gray stuff, and that's a lot thicker, heavier duty plastic. You know, it's much harder to break. You can't just smash. Well, you could smash it if you could smash anything if you put your mind to it, really. Uh, but the Schedule 80 is pretty tough stuff. But I'm old school. I still like using galvanized conduit. It's like EMT, right? Where it's a metal, but I know that and it does have its points. I mean, you get the Schedule 80 in there. It's non-corrosive. You don't have to worry about it rusting, 20, 30 years down the road. It's still going to be in pretty good shape. I just, I don't know. I have a hard time doing things with plastic, I guess, but they are getting a lot better. I know originally some of that stuff was pretty flimsy, or it seemed pretty flimsy, but now their processes have gotten a lot better with that stuff. But so we've taken a look at that. Now we learn how to like calculate our branches through the house and things like that. And that's fairly standard, doing the lighting and then doing all the receptacle layouts and throughout the house. But now we're going to take a look at like the special stuff, right? Like water heaters and excuse me, like furnaces. And I mean, it can be removable appliances like your washer and dryer. And in fact, some of these appliances have gone up quite a bit, where I mean, you have some pretty heavy duty washers and dryers going into a house these days. They go, when they start going with the supersized, the heavy duty loads and all that, of course, what does that mean, right? That means bigger and bigger motors. So your the size of those things has gone up quite a bit. And even to the point where, the same within the kitchen, where people are getting like double ovens and things like that, and and a lot more these days, electrical is becoming very, very much more popular. So these are the kind of things we'll look at. So chapters 15 and 19, first thing we'll talk about is water heater. Now, there's a thing with that. So you get the two types, right? You got the gas style, which you still have to make an electrical connection to these days because they have usually an electronic ignition. Even to the point where now they got, fancy controls on them, USB and Wi-Fi capable and all kinds of crazy stuff with the house. But even the gas ones, you're still bringing in a certain amount of service to it to power it up. But one we're going to look at is the electric ones, and these have become surprisingly a lot more efficient in the later ages now. And they're becoming more and more popular as their efficiency goes up. You have you have this still the tanks where you get like 50, 80 gallon types, but now you've got also the on-demand water heaters where there is no tank and all it is a giant, I don't want to say giant, but it's a pretty good heating element that'll be built into with the water piping and on demand. So it's just instant hot, right? So you've got these types. So there's a lot of new stuff. But we'll look at the water heaters, and you can see here, right? Typical wattage ratings, 15 to 5,500 watts. It might even be more now, but they use a large heat resistance heating element inside of it instead of like the gas with the flames and whatnot to increase the water temperature, and that's both with the on-demand or with the tank style. So here's your standard, and you can see right here, right? These are our heating elements, and they have up, below, and even in some cases there might even be a middle one, depending on the size of the tank. Some places, if you get a fairly large, of course, it matches up how many bedrooms does it have, and that's how you would calculate how much gallons you want to have, right? It's a 50. This would be like a 50 gallon, pretty standard. So you have an upper and a lower heating element to these things. I think the 80s might have 3 heating elements, but so with these guys, you don't actually have a receptacle style plug-in, right? These are actually hardwired in. As you can see here, we got coming from the wall, that would be the service outlet there, right? And then coming through a flex tube or straight in, and there's usually some kind of wiring compartment, like a peckerhead kind of style, right? Where you generally have like an enclosure you'd open up, and inside would be the wiring. They'll have a couple of knockouts on it, depending on what size of that you went with. So very typically, you got about a half-inch knockout to a three-quarter knockout, and then just add, put the connections through, wire it up and whatnot. And it'll have its own dedicated disconnect, the breaker in the panel. But that's very typical right there. And like I say, the only difference might be, depending on the size of the water heater itself. If you get one of the really large tanks, it might even have 3 heating elements to it. But that's your temperature control. The good thing is you don't have to worry about getting any pilot light going or anything like that. There's no gas. It's just basically on or not on. But like I say, they've got the smart ones these days where they even have like USB connections, Wi-Fi capabilities. So it's like basically, with the new age thing. So you get your Amazon Echo Dot going through your house and telling you, it's like, you go and ask Alexa what your water heater's doing, and she'll be able to tell you. But there's very typical heating elements. Depending on the manufacturer, they come in different flavors and sizes, thicknesses. Their essential thing, though, it's it's a resistive element, so that way when we apply electricity to it, it gets really hot. And they'll generally be in some kind of thermal enclosure with like a waterproofing as well. But these are very typical. And usually when the water heater goes bad, this is the first style. And that's why you see on these types that they're threaded like that. So they're made to be able to come right out and be able to be replaced and whatnot. Because over time, these things start to corrode down. You apply, it's not a pure conductor. It's kind of a semiconductor, if you will. So that way, when you do apply electricity to it, that's why it does get so hot. It's not like straight copper where copper just lets it fly through. So over time, these things corrode. They'll start getting cracks to them and things like that. And that's your biggest thing. Usually, you'll end up getting a crack in one, and now it'll no longer conduct through. And there is no fixing them with the type of alloy that they're made of. Usually, once it goes, it goes. But they're fairly easy to replace. And then, of course, as the electrician, you'll have to go through and wire up the controls. Now, usually with these things, and actually with all appliances, they're actually required to come with a schematic and a wiring layout. The tricky part is finding out where it is. But even down to your stove or your refrigerator, generally where the controls are within that, somewhere you'll have to unscrew like a back panel. Same with the stoves and stuff. You unscrew the back panels and they'll usually have the schematics with them and the wiring layouts, and even any special instruction sets and things like that. So you would have to go look and see what your wiring layout and what it requires, and then go set it up. And it's usually like a voltage specific type of thing. So depending on how you wired up the water heater in this case, it might be how this thing gets its different colors rated out to it. So yeah, usually what they'll do is lay it out and it'll be in the control section. So let me go back here just a second. So usually, yeah, you'll bring in the wire into this thing, and then somewhere along the lines, they'll have like control sets, and then you would go through and have to wire that up. And these two, you can see it's a replaceable style unit, because over time, anything with controls or moving parts and whatnot, they will go bad. You can make them as best as you can, and at some point along the line, they will go bad. The only fun part is hopefully it's not too long, because in some cases you might run into my wonderful thing with appliances is obsolescence. So even though, this company might still be around, right? Whirlpool and such, but maybe the thing is like, you got like some 20-year-old water heater or something that's like so old now that they no longer even make a replaceable part for it. And even the off-brand guys don't even make a part replacement for it. That'd be the trickiest thing you would ever run into, really, is the age of the appliance. But yeah, usually they'll have a setting on it, and you want to be careful. Generally, this is homeowner discretion, how hot is hot. So very typically, these big water heaters, you will need a 240-volt circuit, right? So it's dedicated. It's the big ones. They take up a double slot in the panel, and they're usually very settable. It depends. You get the dial type where it ranges in heat. More often than not these days now, you can run into the digital ones where you can literally dial in pretty much the water heat temperature that you want. It's become very cool, but tricky too at the same time, right? But but they have their own. They have a plate on them, right? And it'll tell you exactly all the requirements that it needs, wiring styles, currents, and everything else, just like most appliances, furnaces, even your ovens and whatnot, all have plates on them. So you just look at the nameplate rating, read it off, and it'll specify and what it needs. So, just got to classifies, right? So this one is continuous duty, unlike your other ones, so we have to look at this. And even though there isn't a motor involved, it's because of the heating elements that they treat it like that. So this is continuous load. So we have to look at it in this respect, right? 125%. So we're going to be rating up. So that means generally we'll be pulling a larger wire in and things like that. So the heating elements in these are usually rated 240 volts. And it'll produce a certain wattage at a certain voltage rating. So, and it's just a simple Ohm's law, right? E is equal to I times R. And so, and then P, wattage, is equal to E times I. So you look at your current and your voltage involved. So if your voltage is 240, then your only unknown element in this case would be how much current am I going to be pulling into here, right? That's your current draw. And then that'll tell us, we can figure out what the overall resistance is. Usually the nameplate will have most of this on there and everything. So it's kind of a no-brainer. And then you just pull the appropriate wiring size in. But if we have to go and calculate it, you do have to treat it like this. So remember, it is continuous duty. And so that means we size up. So if the heater nameplate says we have a 5,600 watt, 240 volt, right? So now we got to go and size what? We got to go and size the disconnect, the fuse, if you will. Excuse me. I'm getting a cold, I'm getting the corona. No. So if we look at it, all right, P is equal to E times I. So we just juggle it around, because in this case we have our P, we have our E, and we want to find what? The I. So we go and plug it in, divide 5,600 out by 240, and we come up to 23.3. And then we're going to go 125%, right? So 1 1/4 duty on this baby. And so we multiply that out, see, because otherwise, if we would have tried sizing it, see that, by 23 amps, we would have fell a little bit short in the wiring size and the fuse size, if you will. But in this case, yeah, we go and we're going to put a 30 amp in this guy with the number 10 wire, and we should be fine. So these guys, yeah, this is the one. Now remember, I mean, mostly throughout the house, your the wire sizes you're going to normally be dealing with are very, very typically number 12 and number 14. In fact, that's like the most you'll have when you load up your truck and whatnot. You tons and tons of 12 and 14. And then you got these guys, number 10. Number 10 we'll be using a lot for our appliances. So expect to see that in like the laundry room and in the kitchen and possibly the bathroom, depending on what you never know. They have a jacuzzi or something crazy like that. We might have to consider it, but usually the kitchen and the utility room, laundry room, that type of thing. So we had two elements for the water heater, and they're 4,200 watts each. How much current will they draw? So let's take a look at that. And so now we're through. It's like, okay, what size type? And this is our very, very typical and style that we use in Illinois, right? The THHN, right? Thermal high, nylon sheath, the wire, it's required for this. So if we looked, we go measure it out, right? So we had 4,200 watts each with 240 volts. We come up with 35 amps for this thing. Then we do the 1 1/4 multiplication factor on it, and we end up with just about 44 amps in this case. So we go look up our table and see, okay, normal operation temperature in this area. And remember, you always got to look that up as in your region you're involved. But typically for Illinois, we go with this guy to 75 degrees Celsius. And so we end up with the number 8. And so see, this one's a little bigger. So it all depends, what it's going to require. All your appliances are different. We just go with the name plating and do our math. And these are usually the only things you have to do, right? Figuring out what the service duty is of these things. And all you got to remember is that 1 1/4 up. Because a lot of time, I shouldn't say that. It depends really, but most times you'll always have the wattage that's on there and the voltage requirements for it. And you just go ahead and do the Ohm's law, figure out your current, do the service duty on it, right? 1 1/4, and then just go look it up on your chart, right? You got your Uglies book with you. Go through your Uglies book and look, okay, what size wire do I need for this bad boy? And then you get that, and then you just got to figure out, what size you would need, like with the with the flex tubing you're going to run. And remember, that too can be either metal or these days they have the PVC styles. But you still got to go through and properly size it because you don't want it to be, if it's too tight, you're leaving no room for expansion, and eventually that leads to breakdown, and eventually that leads to fire, and eventually that leads to what? Liability. And we want to avoid that. So, and we go look in Article 422, and that covers electrical ranges. And this has actually changed quite a bit over, I don't know, even more recently. I would say like over the last 10 years even. And again, like I say, more and more of these appliances are getting larger, where people are even going with, in a case like almost like an industrial kitchen, if you will, really oversized refrigerators, oversized double ovens and things like that. And if we're doing electric, and electric's gotten way more popular than it used to be. And that's just because of the efficiency involved. We've gotten a lot more efficient with these things. So we're starting to see more and more of them. Or like, remote areas, like me, our only gas, we don't have a gas delivery out here. It's all propane. So most of the appliances in my house are all electrical. But so we go and size them through, right? We got our building plans, what they're requiring, and then we go and look at what kind of appliance we're going to be installing here. So what do we got going on in this case? So freestanding range. Now freestanding meaning what? That it's a movable stove, right? It's not built into the wall, built into the counter, and that kind of thing. So usually what they'll have is a plug-in style receptacle, right? So with that, we're still gonna, we still got to calculate through. We still got to size it and everything else. We still got to set it, its own dedicated disconnect. And so we still got to apply our math and do it. So, and generally these cord styles are usually fairly big. You have to buy them. A lot of times they don't even come with the appliances. You have to buy them separately and wire them in. And they can have a few different kind of connection styles. Where are we at here? Because if we look, these are very standard style types, and it really depends. So you really have to look at what you're dealing with, okay? And so what kind of, what it's going to have as far as what kind of wiring it has, how many amps it will be, and that dictates what, so that way you can't just go ahead and plug any old thing in there, the wrong type of thing, and blow the appliance up. So you actually have to size these receptacle types depending on the requirements of the appliance. So, and it depends really. So you'll have to look at the, like I say, the range, But usually the movable types don't tend to be too heavy duty, but they're, like I say, they've gone up in size in the recent years. People wanting more and more, and so that's what we have to usually do. So we treat it, either dryer style receptacles, which is like these styles, right? The crisscrosses. Then you have the range receptacle styles, right? The 50 amp, this style. So really you have to look at what, and I mean, both are allowed as long as you have a good solid connection to it. And this will get installed in its own junction box in the wall, usually right behind it. So it'll have a plug-in style, and just size it accordingly, just like we did with the with every other appliance that you would do. They same type of thing, treat it like it is. These guys are not well, and again, so many things with this. They are identical. If we really look, I mean, you get this style to this style, okay, and this style to this style. It really depends on how the wiring is set up for it. Depends on the appliance itself. So you have to kind of look at the whole manufacturer of things with it. And like I say, if need be, if the nameplate's not providing you enough information, usually where the wiring, like when you go ahead and actually add in these cords, where that wiring set goes into, generally there is a set of any special instructions and schematics. So, and it actually for all appliances, even down to the point washers and dryers and that kind of thing, they always are required to have those. It's just not easily findable. So basically, if you need to, you pull those out and read through all of it, do your calculations for it, and decide, what type of configuration are we going with for this type. And as you can see, NEC does allow for all of these styles to go in there. We just have to decide exactly what this appliance is pulling and wire it accordingly. These can be a little frustrating at times, but and it does depend, on the oven itself, what the requirements are. But each appliance, you should be able to go through and look at it. And like I say, if the nameplate does not have enough information, you go in and look where where the cord gets affixed to. Because usually on the one end of the cord, there's like a 3 or 4 wire set, and that'll get wired into the appliance itself. And where that wiring goes into, usually right around in that area, if not in there, there's the schematics and any special instruction sets that they need. And then you get the types that are built-ins as well, which are always fun, but they'll have them labeled out. X and Y are usually your phases. W is like the white grounded conductor, right? You don't typically have, I don't want to even say that, but all right, the 4 wire set. So you would have 2 hots, a ground, and a neutral style. The 3 wire set, it's just 2 hots and a ground. That's these 2 guys here, okay? 3 pole. So, and we've got to think about what do we have pulled into our house, right? we only have the two hots and the neutral, and then you have the ground that you have attached in there. So if we go with this style, you have to look on the sides of these things. There's where the screw downs are. They're usually labeled, and in this case, yeah, just like this, right? So you look X and Y. That's usually for your line voltages. W, if you have the four, the four style like this, the 4-pole. That would be for the neutral, if you will. And remember this, you should usually, this is because a lot of times these things is putting wire in, right? It'll depend, but if you need to, use your colored tape to differentiate, that kind of thing. And then, yep, G is for the ground, and that's pretty standard on all these. That would be your ground connection to these. And the screw sets will be labeled out like that usually, but you'll have like an X and a Y around this thing, and then a W, and then a G, and it'll be in a round housing, and you just apply your wiring into that, if you will. Then you get the fun ones, right? The built-ins, where you could have it wall mounted, the oven mounted into the wall. Some people like to have their cooking stove top units and like an island in the middle of the kitchen, and different. There's so many different styles out there. You have to take what it is. And again, same thing with these, right? They'll have a nameplate underneath it where the wiring generally connects into. And if it's an island or built into the wall, generally you'll have a junction box coming up to that point, and then and you'll attach to it. So usually what you'll do is you'll run the flex to the device itself, have the connector set up, just like with the picture of the water heater, right? You'll have the connector on both ends, going from the junction box running to the wiring connection, the pecker head, if you will, of the appliance itself, built-ins. And then the other one to think about is our wonderful clothes dryer. And he's no different. Well, same deal. You do have the motor and heating element with these things, right? Motors usually to turn the tumble, and then the heating element, and to provide the heat for the drying and whatnot. But so yeah, you got to be careful with these. They can come in a couple of flavors with clothes dryers. You get the standard smaller ones now, and they can very well be just a plain old 120 volt clothes dryer. But then if you get the bigger ones and stuff, you get the 240 volt. And so basically, again, refer back to your nameplate. Make sure you have the correct receptacle style here, right? The cord and the plug styles that are required for it, and go ahead and lay everything out accordingly. But yeah, the most common, just like with the other guys, right? You'll have one of these styles here going into it. But the most common is usually this 4-wire 30 amp receptacle behind it. But again, check the nameplate, make sure you don't have any special considerations for it. You can, you can. The whole thing with the clothes dryer though is I got to think it's movable, but you can, and in some cases, do a flex connector directly to the clothes dryer. I have seen it done. Like, you'd have to think of it being, this is like a permanent replacement, if you will. I don't like doing it just because it is a movable appliance generally. So you have to take that with a grain of salt, kind of protecting the homeowner from himself, if you will. But if you look, yeah, we can definitely run a flex to the clothes dryer with a whip and go with it about like that. But it just bothers me. Like if it was my own in my house and I had something like that laid out, of course, I'm not going to go yanking on a clothes dryer and end up ripping it out of the wall or something like that. But some homeowners are creative, so we got to kind of protect them from themselves, if you will. But this style is allowed, where you don't have a cord coming down. You just literally have the whip coming from the junction box directly to a clothes dryer like that, and it is allowed. Generally have your coupling on there, right? You got an EMT drop coming down straight into this guy. So you wouldn't have like a junction box directly behind it. It might be up in the ceiling somewhere, that type of thing. But this is the more standard style. Usually I'll have the, and again, remember, ground plug up, up for these guys. I know the older styles, they're still grandfathered in, but yeah, when you do new installation, you want that ground plug up. Yeah, NEMA, I think I've talked about that before, right? National Equipment Manufacturers Association. They're not with the NEC or anything like that. They got together a long time ago and decided what average voltage ranges should be for all devices and appliances, and make it uniform and required for like all utility companies and electricians and whatnot to basically install wiring that delivers that. That's why we do like the voltage drop, because if you go too far out and your voltage falls below that, your equipment can't run properly anymore. And that's when you get NEMA involved, and that's what it always refers back to for all appliances or electric or electronic devices. But here this picture shows, yeah, it's a 4-wire cord, right? You got the 4-wire 30 amp, 125, 250, depending. So, and you get the 3-phase R in there, and it's pretty standard. But yeah, usually right, and believe it or not, right where that usually gets installed, you'll like behind there or right behind there. If you go ahead and remove those service panels, that's usually where you'll find like any special instructions or schematics should be somewhere back in there with the from the manufacturer. So, yep, we got a heating element with these guys, and you have a motor. Oh yeah, and sometimes the lamp light that comes on when you open up the door, if you will. So again, refer to the style that it is. It depends on really the manufacturer and how they have it laid out. So you do have to go through and wire it accordingly. And that's a lot of times what you'll get, the 4-wire style. So you do have, we do have a neutral coming into it. And so what would happen is anywhere in here that's requiring a 120 will only pull off of the 1-phase with a neutral combination, whereas the special ones like, the motor and will probably be just running on the 2 hots and ignoring the neutral. But that's when you get, a combination device. See how it says 125/250. So it's using both. And that's why you would go with this style. And that's essentially, let me go back here, what it means when you do these styles versus this one. So the device requires no combination voltage like that. So, a lot of times, some clothes dryers are the very basic one, no light comes on or anything like that. Window mounted air conditioners can usually go with this style, but if it has combination voltage of some kind where it needs a neutral, you would have to be with one of these 2 styles here, because with this style, there's just the 2 hots and a ground. With this style, right, we have the 2 hots, a neutral, and a ground. And that's what it means for that type of thing. That's generally what you're going to be looking for. So we look at the calculations, right? We go, in this case, the nameplate's telling us we have the 5,000 watts. And again, we go with the higher voltage, so we determine our 240 volts for this case. And that way we can size the breaker accordingly with this guy. And these are very typical. Sometimes they come with these guys on here and sometimes not. The enclosed loop styles are nice because even if the screw becomes loose, this will not fall off. Whereas the open prong style like this, if the screw does become loose over time, the prong, especially like, you get something like a dryer where you get a good amount of vibration, let's say that that nut backs off a little bit, and over time, with that open prong like that, yeah, that could slide down. So, it's a pain in the butt with these styles because you got to back the screw the entire way out to be able to mount it on or take it off, kind of thing. But you do have that added safety factor in there that even if the screw becomes a little loose, this baby is not going to come off. Whereas this one, easier to install, but over time can come off. So they both have, their pros and cons. They both work. I mean, generally, as long as you tighten these guys down to a good torque spec, you usually won't have too much of a problem. And generally, you got to take everything with a grain of salt. Usually, your appliance, how often do people actually keep an appliance for over 10 years these days? Not too often, but it does happen. And that would be the drawback on these is well over time that they could come undone. I don't know. So interesting little installations here, right? Oh, God, so awful. But a good one, right? Mounted in the wall. And you have these 2-gang plates like this. And the style, basically, what this sets up for is that you're not allowed to add any other type of device into this junction box here, right? That this one literally will take up enough room that you can't fit anything else in there. And unfortunately, you will run into things like this. Homeowners don't usually look at overall stuff. They'll generally just go ahead and install things, if you will, just for ease. So you've got basically, that looks right to me, it looks like just basically like sheet cable just coming right up into there, right to that junction box. And then you got this nice nice metal contact here, right next to that. Ugh, so awful. Yeah, and if you walk into this, I don't know, you might want to turn around and walk away. But this is an apartment building in the basement, if you will. So each one of these is a different service for the apartments, right? And, homeowner just basically, as they added on over time, you get, oh my God, so much unsecured fastenings, over equipment where it shouldn't be. Typical basement for the dryer. Yeah, you'd be amazed. A lot of times you will find that. And there you go. Somebody got a little creative. I believe it's a doghouse, but and yeah, you got a lot of current with these guys. So depending, you get a little water in there, that kind of thing, and whew, all depends on how it was installed, where it was installed, and that kind of thing. Yeah, it can. They're not very forgiving, and when they go, and they go big. I have seen this so many times, and you'll go through, and it depends too. It could be on the receptacle side where it's torched out, but it could also be over on this side. Oh, really? Yeah, it depends. I've seen flare and flash, but yeah, when these things arc, they arc big, and they go quick. But that's a nice, nice easy install. Here you got the 4-prong style, right? Nice secure, ground plumb up and whatnot. Good EMT mounted to to the cement wall here. And like I say, all metal. You can, I don't know, you can do the plastic, but I like all metal. It just, to me, that just spells durability. It looks strong, you're good. It's grounded all the way around. So if something does happen, it'll ground out, and that'll be that. But yeah, you're allowed some creativity and room as long as you size accordingly. And like I say, people do get creative. You got to protect them from themselves. And this is, yeah. And see, And there's the one drawback with using when you start getting into this, the non-metallic sheath cable like this, is people will tend to treat it like it's rope and literally just start hanging it and fastening it all over the place, not even thinking that it's, that this stuff is, you got some, we got, I don't even care if it's just a regular, if I got a 20 amp service or something going through there, 20 amps is 20 amps, that's a, that's, that's a bit of juice, but it just hurts my head. But you got it out there. And generally you'll walk in and you'll have to deal with it, right? This will be your service call and they want to add another circuit on or something like that. And so and if you're working for an electric company and they say to do it, then you have to do it. It doesn't mean you have to follow their work, you just still do a good job, do the best you can with it, mount everything up. You can't, you don't have the time and whatnot to be able to clean this crap up, right? You just have to deal with it and let be as is. As long as your work is done well, then that's the main thing. And yeah, I've seen this more often than not, believe it or not. Like I say, when these things go, they go big. It could be different reasons. I mean, even you got to figure clothes dryer, it's got a moving motor. If something happens, I don't know. People tend to like to throw gym shoes in the dryer, right, and not watch them, and a gym shoe will end up getting wedged inside of there somehow, and so the motor's still trying to turn, and so and you think about that. Okay, what happens? So gym shoes in a dryer get stuck in between those. I don't know what you call those little fan blades, that tumble it around, right? And it gets stuck in there, and then the motor's still turning. So now it's got basically it's one of those, the immovable object type of thing. So what happens? Well, your current will start spiking up, and if there's, you always end up with what's your weakest link. And in some case, if the thing is old, even to the point, let's say one of these screws was a little loose where you had some vibration to it or something, right? That's a possible arc point that very typically won't cause a problem, but in this case, yeah, it got overworked and then arced out and made contact with another side and then let her rip. Usually what'll happen, your service your fuse will go or your circuit breaker will flip along, before this becomes too much of a problem, thank God, or it'll just ground out right and short out. But yeah, that's toast. But that's what I have for you gentlemen today. And then we're going to go here. Let's see what I got. Oh, I got to find my thing here real quick. Oh, hold on a second. We're getting down to the end here, aren't we? Sure. Oh, good God. Sorry. I never did go to school for video conferencing. There we go. But let's see. Yeah, see, one of your labs at this point, we would have gone through and wired up a receptacle like that style, right? Go through and see the two styles that there are. But what do we have at this point? All right, the chapter, look at their course calendar. So at this point, yeah, you should have finished up your two quizzes, hopefully. And then coming up by Friday. And I'm sorry if because usually I had a password protect, because usually you did these, in class, and you'd go over and get on the computers and you'd take an hour and take your quiz, right? But now we got this all take home stuff. So I trying to remind myself to take the password protect off of these. So hopefully I did. And then we got the homework here. Yeah, chapter 7 quiz. Yeah, due by Friday. It shouldn't be too bad. And then we do I lumped them together. There's the chapters 15, 19, and whatnot. And at this point, we start getting closer to the end. My lectures start lightening up. And the reason being is we're going to start getting more, more into labs and stuff like that. But I got one coming up. I'll give you an NEC code challenge. Basically, look at the picture, even an Uglies extra credit if you want. But we'll do chapter 26, and I'll have my third Uglies quiz coming up, and we'll continue on with the special outlets. We'll look at the second half. And it's kind of, like I say, I try to get through this class. We try to look at most of the, the average things that you would run into in a residence. And there's always going to be stuff that, be special, but and when you get to something special, you always want to take time out and look at it that way anyway. But it's not a very typical, it's not like, every house does not have a jacuzzi or like a steam room or some kind of wine cooler room and that kind of thing. So we won't be looking at those so much. But most houses these days do have these general appliances, usually the washer and dryer set, and then more often than not, right? And in any case, some kind of a range in there, even if it's a movable range, or some of them, they're becoming more popular, the built-ins. And one I've noticed a lot is refrigerators are becoming much, 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 much larger these days. Even my sister got one it's pretty humongous. I was thinking about it, but I don't know. It's just my wife and myself. I don't know if we need room for that much stuff, but anyway. Oh, I forgot to flip up my little hood. I'm sorry. Yeah, my wife got this video camera, so it's got like a little flip down hood on it, so nobody can what do you call it? Video hack me, I guess. Since I'm not so good at all that hack protection stuff, but that's what I got for you gentlemen today. You guys doing good? You got any questions on any of this stuff so far, or is it making sense, if you will?
Making sense so far.
Huh?
So it's making sense so far.
Okay. Yeah, and a lot of these, like, we talk about like those range cords and stuff. Usually those are all like in a multi-strand style. So the screw styles are built that way, and they'll have like lockdown tabs to them. So usually the way they're designed to be is you pretty much strip off like so much on your of your insulation, if you will, and you slide it in. Those ones multi-strand, I'll warn you, it does not curl very well. So if you did end up doing like a curl, like you want to try wrapping around the screw, those suck. It's because it will not. Usually when you try clamping a screw head around a multi-strand, like on a curl, what it's going to do is it'll flare it out. And so a lot of times you want to go with what they'll have is like a screw with a square clamp tab that's right behind it. And so that way when you screw down, that clamp tab just basically locks down onto the wire. And that's the style that is usually preferred for multi-stranded, because multi-stranded, once it gets wrapped around like that screw head, it'll mash and it'll start to flare out. And so now you create little arc flash points and stuff like that. So you got to be careful when using those things. But yeah, the good thing is a lot of these appliances though, and even the crappier, I don't want to say trying to say anybody's crappy, but the cheaper version appliances, if you will, even those, they always have a pretty good set of schematics and special instructions, so you can always go and look at those. It just like the nameplate doesn't seem like it's making sense or something like that. So just always remember, you can dig them out, and usually you'll find them pretty close to wherever the wire housing is. That's usually where they'll have it. Usually it's a pain in the butt because you usually have to take off the appliance service panels, and they usually got them screwed down with about 6 million different screws or bolts. So you have to go through that part. But other than that, yeah, usually you can get all the special instructions, and that's water heaters, furnaces, and ACs, all of them. They'll always have that. You got to be careful with some of the creative homeowners. Sometimes do take them out and put them like in a special folder, and sometimes that folder disappears when homeowners change hands, so you might run into but in this day and age, the cool thing is a lot of times, and in fact I've had a pretty good degree of success trying to look up schematics online. If you do have like the manufacturer and the model number and stuff like that, more often than not you can usually get them, right on your cell phone, which is pretty sweet. So if you do run into a case where you come across an appliance that does not have those schematics and stuff, don't get frustrated or bent out of shape yet. You're not done. Go and look on the nameplate and get that model number and serial number and the manufacturer, and go pop that in online, and you'd be amazed. If they don't have the dead exact one, they'll have something like very, very similar, which is pretty nice. It's one nice thing about having the World Wide Web out there available to us. But yeah, that's what we got today. Looking at special service stuff. And again, we'll continue on with this. We'll look at the second part on next Tuesday. Right? Or what day am I on? God. This stay-at-home stuff is killing me. This Thursday, right? Oh, Jesus. See? I don't even know what day it is. No, but yeah, this Thursday we'll continue on with it. And then, and take a look. We got that homework set due, and then we got our last Uglies quiz coming up. Those quizzes, they're not too bad, right? For the Uglies, it's just like trying to look up the information in the Uglies book and looking at the tables and charts and the formulas that they have in there. I just wanted to get you guys into using the tools, and don't be afraid to explain some of this stuff on the homework. And the reason, all right, and I tell this to every class, and I'm going to warn you out there, and it's like, yeah, we're not here to, we're not getting into the thing where, I'm going to write novels, right? We're not going to be book writers or nothing like that. But in this day and age, when it doesn't matter what kind of service technician you're going to be, residential, commercial, industrial, controls, one of the 6 million different other electricians out there. 9 times out of 10, you're going to be required to do some kind of daily log, work orders, like I say, a daily log. It's like, and your boss is, you got to account for your hours of the day. It's like, oh, you work 12 hours this day and that kind of thing. And you have to account for that, And so what I used to do, because, by the end of the day too, especially if you're doing like a few different jobs, I used to carry around I'll show you. I even got one right here. I always use these things, but these little spiral notepads like this. I always carry these around, and then what I would do, at the start of each day, I would actually put on the top the date and the day, and then I'd start off. You start at 8 o'clock, you start 6 o'clock, you start whatever, and you put 6 a.m. Start, and then and I wrote down like all my jobs I did in a day. Even if it's, something silly, it's like, okay, went and took a look at this, kind of thing, had to reset this, the GFI in bathroom 2 or something stupid, but you know, it's time. So, and then I would, you know, write down the time involved. So if I reset the bathroom and, I mean, reset the GFI in bathroom 2, you know, there's 10 minutes because I had to get there and this and that. So yeah, you write that all down. And that's the reason why, you know, writing, you know, summaries and things like that, or even these essay questions, it's because when you get out there, you have to be able to report in a, and not really detailed, but you got to give like a fair, you know what I mean, a fair amount of detail to what your job was that day. Because you know, you got to remember, it might be your boss or your boss's boss that's going to be looking at it at everybody's thing at the end of the week, right, to justify all our hours and crap like that. You know, and he's remote and he doesn't even, usually you don't even see him, but maybe like once a week or once a month for like team meetings and crap like that, right? So he's not going to ask you every day, hey, what'd you do today? You know, no, that ain't how it works. But yeah, you got to be able to, and that's the reason for this, is just to be able to just write in detail, like, you know, what you did. And just usually I just go step by step, you know, nothing, you don't go crazy and elaborate, you know, if you're pulling pulled new service into the you know, installed a receptacle over here, blah blah blah, you know, that kind of thing, and then record your time with it. And that's the reason why I throw this at you. I mean, it does not matter what you're going to get into, unless you get into, you know, your own in business by yourself. But usually starting out, you're not at that point yet. So if you're working for somebody else, they usually want some kind of log, and that's why we do this. Get you used to writing technical. You know, it's always, you know, it's just like cops, right? Just the facts. You want just the facts. You don't have to get crazy and elaborate. You know, the birds were flying by, you know. But you do have to be able to report what you did in a day. And that's almost always a requirement to a certain point. I know, actually, yeah, just about every technician job I had out there, I had to have a daily log. And that was usually the end of your day. You go on, hopefully you get it where it's by the end of your day, because, you know, but that's why I do the, well, you get out of here, dog. That's why I kept my little notebook. I always had a little notebook in my one side pocket. And I usually wrote down all my jobs. And that way, even still, you know, a month down the road, boss comes up to you and says, hey, what the hell was the deal with this 5 hours on this, you know? And you flip back, oh yeah, let me go look. That was in April, you know, April 10th, right? And I go, yep, see, that's what I did. I did this and this and this. Because I don't know, if you're like me, you might sort of remember the job that you did, you know, a month ago, but you're not going to get all the details. But that's why usually I do that. So I write down the details, and I write down the time involved for each one. And then that way I always can look back. And I used to keep them, believe it or not. I had basically I went through 12 of those little notepads a year. I kept one for every month, even if I didn't finish it. I was like, nope, that's January's notebook, and here's February's notebook, and March's, and so on. And it's just handy. It's a handy thing to do. Even in this day, you know, where we do have all the electronics for doing our work reporting, and that's part of the problem too, is we do have all these electronics for the work reporting. So, you know, usually your boss by the end of the day wants you to have some kind of like electronic log in there. And there's so many different softwares out there that do that. But yeah, you're gonna have to. But in some cases, still too, you do have the, you know, but he wants a final worksheet of the day kind of thing. So you still, so you just gotta sit there and fill out your worksheet, turn that in, and count for your hours of the day. And they'll give you a time, you know, getting to the job, getting set up, and, you know, lunch and breaks and crap. But like in a 10-hour day, you had to account for about 7.5 to 8 of those hours in a day. You know, and they give you 2 hours out for breaks and travel and setup and that kind of crap. But yeah, you will have to do that. And that's the reason why I do the, you know, essay style questions, or even like some of these article summaries and stuff like that. That's the purpose behind it. I don't want you writing, you know, like, you know, like your Stephen King writing out novels and stuff like that. The sky was a peculiar blue today. I don't give a shit, but but being able to report technical is important. It is important for us. Just, and like I say, just like cops, right? Just the facts. You got to be able to do the facts. Does that make sense? Anyway, sorry, I got rambling, but that's why we do stuff. And that's why I try to get everybody writing a little bit. It's important for you out there, and eventually, because you will be writing that up. And if you end up becoming like a team lead and a supervisor, oh my God, I'll warn you, you'll definitely be doing some writing then. It could be and it's like I say, we're not writers typically, right? We're not about that. We're worker kind of, but you do have to do it, especially these days. And more actually, the more, oh God, especially if you're working like, if you go industrial and end up working in a warehouse, they almost always, you got your work orders and you got to fill that. I used to have to fill those out all the time. And that was the last half hour of my day every day, was filling out these stupid work orders and having them make sense to a certain point. But yeah, anyway. But all right. Yeah, if you guys don't have any questions, that's what I got.
I have a question. On the it was like the last question on the Uglies Book quiz.
Uh-huh.
It's like about rigid PVC. I think it was about.
Uh-huh.
It was finding the size, the size, the trading, the finding the size.
Right.
It wasn't really specific on which chart you're supposed to use. It said like 3 large rigid PVC with at 2.4 square inches.
Let me pull it up. Go look at the. Oh, what day was that on? Uglies Quiz 2, right? Yeah, so you plan to route 3 large conductors through Schedule 40 rigid, right? So your total conductor area is 2.4 square inches. What's the minimum trade size PVC conduit that you can use? And that should be in there. It doesn't matter what version you use. That part has not changed.
Was it like where we supposed to convert the 2.4 square inches into something? That was really like confusing.
Oh, it has it in there, Jared.
I didn't notice it if it was in there. If I couldn't notice it.
Oh yeah. Yeah, every one of these can be found in that Uglies book. Unfortunately for you. Hold on here. I gotta find. Of course, now I gotta go through this electronic version of this book, which I'm not used to doing actually. It's usually we be in class and I can go through and flip it right through there. All right. What do we got? No. Well, this is hard to see, huh? All right, let me see if I can. You see that, can you?
They can see it.
All right. So what did we say now? I'm pretty sure it comes out to, oh, that's metallic tubing, right? What are we looking for?
Was like rivet. I think it was like rivet. It was like Schedule 40 rigid PVC.
Right.
At like 2.4 square to like 2.4 square inches.
Right. That puts you right there, buddy. See that? And that's why. That makes sense.
It was rigid PVC, not liquid tight flexible metal conduit.
Rigid, I'm sorry. Okay, rigid PVC. I don't know where I'm going. All right. And again, why can't I go down here? It's, what was the size? So here's 2.29. It'd be too damn small, right? So we got to go next size up. So we go number 3. Yeah, that's Schedule 80, rigid PVC. Am I right on that? Pretty sure.
I'm pretty sure. It's,
Right.
I guess thing for sure. Like,
So remember that with this, because you can't go, you know, and it's a rule of thumb with everything in electrical, right? Always go next size up. If you're dealing with, especially with fractions, don't run it tight. If it looks like it's going to be marginal, go next size up. The cost factor is not going to be that much. You know what I mean? For us to go literally, I mean, 2.5, technically, we could probably get away with it using 2.5 inch, right? But it would be tight. And so going from 2.5 and stepping up to 3 would not be that big of a deal. And this way we do have the room and that kind of thing. But yeah, that's how we look at, right? And I mean, it's got every type, which is cool, because you can go through and look at every type of raceway that's out there pretty much. Yeah, liquid type, excuse me, rigid metal. It's like, you know, all these crazy ones, and it depends on what you're dealing with. And you got to even be careful with some of these. You know, it's like, what is pipe. I mean, when I did residential in Chicago, that's usually what we used right there was the EMT, when they call it. And notice from here, they call it tubing. It's not even really a pipe. So if you misconstrue and think, oh, I have rigid metal conduit. Oh, it's like, do you? Or do you have electric metallic tubing? And so, yeah, these things, ugh. And there's so many things, and you have to apply it to, you know, what you're dealing with. And like I say, you know, Schedule 80 is typically what you're going to use, you know, the gray stuff. It's thicker, heavier duty. Schedule 40 is the cheesier. That's the white pipe. And you could, just between me and you, I hate using the crap. I've said that before. It's plastic. I hate using plastic. I don't like it, but in this day and age, sometimes we do, you know, and it does have the cool thing is yeah, it's plastic, so it does have the weatherproofing behind it, so it does, and it can. I mean, if you want to make this thing last, you know, you're 25 and you're buying your house for the first time, and you plan on living in this house for the rest of your life, so you go ahead and you can go ahead and yeah, do the plastic and stuff like that. But I'll warn you this too, even though it's durable for weather conditions and stuff, the part where it doesn't hold up is you got to figure how plastic weathers overall exposure over time. Sunlight hitting it, going through the freezing temperatures, sunlight hitting it, freezing temperatures, you know, year in, year out. And after a while, plastic starts to degrade, whereas the metal would not. So you got pros and cons with both styles. But anyway, see, now you got me all going. But yeah, that's how you look at that, buddy. The next size up, that would be right there, number 3. Right? I'm sorry. I had to grade you hard on that one. But yeah, look at it. Dimensions and percent area, conduit and tubings. Now, pretty much they got all the sizing things for that. But yeah, these would be all the styles. And that really has not changed from, the various upgrades and stuff pretty much since 75, I think. But even down to, yeah, and these are your different dimensions and drill tap sizes, that kind of thing. What you're going to be doing when you bore out, what kind of connection you'll need, a connector for that, right? But yeah, this thing is, I love this book. I do. But yeah, always take that with a grain of salt. Really look at what you're dealing with. What is rigid metal conduit versus EMT, where it considers it to be tubing versus being a rigid metal conduit. And you can run into rigid metal conduit. That's some thick stuff. It's usually heavy duty. Can be very difficult to bend. And that's why when you do get into piping and stuff, the EMT is more popular because you can use a pipe bender on it, and bend it, give it offsets and that kind of thing. Whereas you start getting into this stuff, and it's a lot of times what you're dealing is threaded. So you'll be screwing on connectors and that kind of thing. So depends on what kind of areas. Some cases, like you get into some factories and stuff like that, and where wiring has to go through, and it's like considered a corrosive area, corrosive element. They might require you to go with this really thick walled stuff, in which case, yeah, you'll be threading it and going through and doing that. But yeah, it's everything. But yep. That's schedule 80 Rattler, or schedule 40, and even down to the weird ones. This stuff, it depends. It really does depend. Depends on your work situation, but we've got the sizes for all that. And part of it comes down to, right, it's like, what is my inner diameter? And that's because the schedule 80, see, if we look, what's our inside for that versus the schedule 40, I got a lot more room in schedule 40. And it's thinner stuff. It's not as thick. So the schedule 80 is gray, real thick, heavy duty stuff. And then the schedule 40 is the white, typically, thinner wall. But does that answer your question, sir?
Yeah.
All right, I'm sorry. But yep. That's why I do this. So we do have to look up stuff in this Uglies book. And it's got a little bit of everything for everybody. Oh. Even the crazy wiring types and stuff that you may never ever run into. It really all depends on what kind of job you get into. I mean, there's one you run into almost always, and the outside version of itself, right? Wet. But then you got all kinds of, really all depends on your situation, and it's your nylon insulation types. But yeah, this book is awesome. I love it. It's your Bible, and I want you to learn to use it, and I want you to use it. Anyway, but any other questions, gentlemen, or we're good, or? Oh, don't be shy. Yeah, otherwise, we'll stop sharing that. All right, I think I'm gonna go make me a sandwich and have a late lunch. You guys behave out there. Be good. I know springtime's coming. Remember your social distancing, 6 foot. Stay safe if you can. Protect yourself from the weirdos out there. even if they aren't wearing face masks and they don't know how far 6 feet is. But all right. Otherwise, yeah, I'll see you guys on Thursday, and get a hold of me if you have any questions and stuff like that. All right.
Okay.
All right. You boys have a good afternoon then.